Hello guys, welcome back. In this video, let us understood the important notations or the famous notations that we need to understood, or what are the notations that we use while training a model or while using a model. So those we will understood. Either the model will be a basic ML model or a machine learning model that is designed by using a neural networks or advanced generative AI models which are designed by using a transformers architecture. So whatever the model may be, what are the general notations or famous notations that we use to represent the data? Let us assume I have an issue or I need to perform some task. For that, I've already selected an ML model. Now, what are the notations that I follow? Let's say for my specific case, I need to generalize or I need to fine tune or train this model. In order to train this model, so while training a phase, what data we will send to this model? We need to send some training data. That training data we will send to this model. We can even call that training data as historic data. In this training data set or historic data set, what are the values that we send to our model while training? We will need to send. So for what input, what is the expected output that we need to send to this model while training, right? Yes. That input contains the input features. We call each and every input value as a input feature. In specific, how we represent that input features. Let's say only one feature or one column of data that we are sending to our model while training. That we can represent by using small x. Let's say if we training our model with multiple columns of features, then we represent that notation with capital X. After, so while training this model, we also need to specify what is the actual output that is expected, right? Yes, that a target we need to specify, that is output target we need to specify. Then how we represent that output target while training this model? We represent that by using y. This normal y indicates the target column. Since the target is nothing but if it's a single value, then we can represent it by using a small y. Single column, then we represent it by using a small y. So these are the notations that we use while training phase for this ML model. Now let's understood what are the notations that we use while testing. After training this model, we definitely test it, right? To understood the performance of it, we definitely test it and we use it in further. While testing also, we need to pass some input values, right? Yes, we need to pass some input data set where we just pass our input features, right? Yes. So then what is the output that we are getting? That output we are getting is nothing but the predicted value. That output we are getting is nothing but the predicted value. Who predicted this? This ML model. That we need to represent by using y cap. Since it's a predicted target, predicted output target, we need to represent that data by using this y cap notation. So while representing the predicted target, we need to represent it by using y cap. In order to predict this output, let's have a question. How this ML model will be? How this ML model will act in between my input as well as output, nothing but my input features and my target features. It acts as, this ML model acts as a relation between my inputs as well as my outputs, right? Yes. that relation function, we call it as f of x. Actual relation function, we call it as f of x. Y is nothing but the actual output, actual target, and x be the input. For specific input features, this is the exact output. So that relation we represent by using this function f, that is nothing but our model. Okay. In real time, what happens is sometimes, not only sometimes, every time while selecting a ML model for specific task based on inputs and expected output, we need to identify the relationship between our input and the actual output in the form of a function. That is a relationship between input and output that we need to understood in the form of a function, and we need to implement that. So for us right now, already there are some famous models, ML models are there. They are providing specific functions for specific tasks. So we need to select specific function based on our specific task. Then we need to train those ML models. Then we need to use those ML models for our specific need. Nowadays, this is what the process is happening. If in case our required ML model is not there, that is our required exact relation between input and output is not found, then we are the persons need to take care of creating or defining this function. So let's say we predicted the relationship between input and output. That predicted function, we call it as, we represent that by using f cap notation. So if the function is a predicted value, then what is the output? Do we get the exact value? No, the output also will be predicted only. So that's why we are representing the output as well by using y cap. So for passing this input features x to our model, where this function represents our model, this function will provide us, or our model will provide us the predicted output, nothing but the y cap. In real time, there is a gap between, there must be some gap happens in between the predicted value and the actual output. So we need to decrease that. So in order to use best algorithm, ML based model, we need to reduce that gap between the actual output as well as the predicted output by doing some, by adding something to our function, or by increasing or updating our actual function, that is nothing but our actual ML model. That is the actual goal. So while implementing or while selecting the model or while designing any ML model, our goal is to create a ML model with, or identify an ML model related function which provide a relationship between the input features and the output, where the predicted output, the difference between the actual output as well as the predicted output must be very minimum. If we see the goal, or if we frame the sentence of the goal while designing any ML model is design f cap of x, nothing but the relation between the input as well as the predicted output, such that the difference or gap between whatever the predicted output that we get and the actual target, the actual output must be minimum. We need to reduce the gap between these two. that is the value that we predicted, the target that we predicted must be same as the actual target. Like that, we need to predict the output accurately as much as possible by using our ML model. So in that way, we need to design or select our ML model. This is the main goal. We need to predict the target exactly as much as possible, and we need to achieve the task efficiently. That's what the main goal while creating any or designing any ML model. To predict the exact target, we need to minimize the distance between or gap between the predicted target with actual target. So that's what we need to do. Okay, we represented the input features, output features, and predicted output and predicted relation, as well as we even discussed about the goal. Now let's also discuss about how the training data set or historic data set will look like. That data set we represent by using capital D, where this historic data set or training data set must contain the input features, that is capital X or small x. If the input feature is nothing but a single column, then we call it as small x. Multiple columns, then we call it as capital X. And we need to provide the target as well. So while training our model, we need to provide a data set, training data set or historic data set. We call it as that data set must contain the input features as well as the expected output. So we need to train our model based on these data. Now let's understood what is meant by this training. Let's say I pass this historic data set or a training data set to this model. Then what is a training? What do you mean by training? Training means, so first whatever the data set that is provided to this model, that data set need to be analyzed by using this model, right? Yes. So first the data set need to be analyzed. After analyzing, this model need to predict new rules, whatever the updated rules that have been designed based on the historic data set, those need to be predicted. After analyzing that data set, this model need to derive their own rules based on this data set. Then after deriving the rules, that rules need to be interfaced to this model. So what is meant by training? Training require these three tasks. First one is analyze the input data set for training and predict the new rules based on the data set that is provided to this model. After predicting based on the analysis of the data, that rules need to be interfaced to this model. Then only this, after interfacing the rules to this model, then only this model can able to predict the output based on this trained data. Based on this trained data, predicted new rules, it can able to identify the results for given input after interfacing those rules only. Actually, we just implement a specific method, whereas while training, after implementing that train method or fit method, this all tasks will be performed for specific model that we select. Or if the model is actually our predicted model, then if the model is not a predefined one, then we need to perform these tasks. Now, let's categorize our real-time problems into different ML model types. Let's say if I have inputs, let's say if I want to ask my model with already trained data, that is nothing but I have trained my model with some data set. with some large data set. Now I'm asking my model a question with the same input. Nothing but while training, whatever the input that I have provided, the same input that I am providing, the same input that I am providing, the same features that I am providing to predict the output. Since our model is already trained with that input and our model is already known that particular output, since this is not predicting, it is directly providing the available output based on training data, we can categorize that type of problems, such type of problems, nothing but the input features are already present, are already trained to our model. Nothing but the input labeled data is already available to our model and output is also available. Then such a type of classification or regression, we call it as supervised learning problem. In some cases, whatever the data that we provide, that data related input features might not present while training. So such type of problems, what do we say? Such type of problems, we need to predict the output because the output is not trained with it. So our ML model need to predict the output. So such type of problems, we call it as unsupervised learning problems. Don't worry, I'll explain you with a small example. Let's say I provided a cat image. I provided a cat image to my ML model. While training, I already provided that cat image to my ML model. And I labeled that cat face and I provided that image to this model. Then what happens? This model will predict that while training, this image is already used for this particular target, that is this represents cat. So that output it will provide, that classification it will do. So that type of problems we can call it as supervised learning problem example. Let's say if I am providing a cat, but such a type of cat is not used, such type of cat photo is not used while training. Even I'm not labeling the cat face exact where the face of the cat is. That face is not labeled. I just provided the cat photo to it and I even not label the cat face. So during that case, what our ML model need to do, it will classify, it will need to cluster whatever the given input into specific category. Whatever the training data that it has, based on that training data, this ML model need to categorize or cluster the provided image into any one of the category. Such a type of clustering we can call it as, such type of clustering categorization we call it as unsupervised learning problems. So this is comes under an example of unsupervised learning. So these are the notations that we use to represent the data, and this is the goal that we need to remember while selecting a model or while predicting a model. And in this way we need to categorize our ML model based on real-time problems, either it's a supervised or unsupervised learning based problem. Those we need to categorize. And this is what about training. So while training, these tasks will be happened. I hope you understood this video and you got some knowledge from this video. And I feel this video is useful. If you feel this video is useful, then please like, share, subscribe, and hit the bell icon to get the latest updates. Thanks for watching again. See you back in the next video with another interesting topic. Until then, bye bye, guys.